Let's discuss one more method of solving recurrence relations. So the method which we call it as a recursion tree method, like solving recurrence relations using recursion tree method. So here like what we can do is we can just expand this recurrence relation in the form of tree, and as what we have discussed when we have just doing, like in this case what this recurrence relation does is t of n equal to t of n by 4 plus n. So now what exactly it is doing, the problem of size n is divided to problem of size n by 4, like sub problems of size n by 4, and then the time required, local time required for dividing that problem is n. And then we were trying to replace n by 4, and we were just going on solving that relation, and we are coming with like what will happen at t of 1 case, right? So now for this case what we can do, like let's say if we replace now n with n by 4, because now our replacement is anyway n by 4. So now in this equation which term we have? So anyway t of n by 4 we are going to replace, but what will happen if I replace this n also by n by 4? So what will happen, you can say t of n by 4 is this one, so that will go by n with n by 4. Then what will happen here in this problem, it is n by 16, and only one change is there. So here no branch is there, let's say, but you can see here now n is replaced by n by 4. So what will happen to this n? So n will going to n by 4 in first phase, then in next phase it will go to n by 16, because again at each stage what I could say is here I'll replace n by 4. Same way at this stage I'll replace n with n by 4. So this is a very general and simple example I have taken. Now again the tree will proceed like n upon 32, and this will be reaching till we reach theta of 1, or that is our t of 1. Now what will happen, like at each stage we had this n replaced by or n has been changed to these values. So now our entire thing will be simplified as I have to sum each and every level of this tree. Now this is just one-sided tree, and now if you just see that n by 4, n by 16, n by 32, and these things I will be summing. So I will be summing n plus n by 4 plus n by 16 plus n by 32 plus so on terms. I will go till I will reach to that part will be converted to 1. So now if I take n common into this, so what will happen? I'll be getting 1 plus 1 by 4 plus 1 by 16 plus 1 by 32 and so on. And this is, if you look at this series, this series is a geometric progression series. Geometric progression series. So now if I calculate this answer, the final answer of this geometric progression will be some constant value I will be getting, right? Because this is a geometric progression. So when this implies some constant, so we will have n into some constant c, I could say. So we have got the term n. So we can call the complexity of given recurrence relation with using recurrence tree. So the given recurrence relation was t of n equal to t of n by 4 plus n, and for this recurrence relation the complexity that we will be getting is, the complexity will be somewhere around theta of n. Okay, so usually we can choose a theta notation here, or even you can say big O of n, sorry, not omega, big O of n. But the problem with this recursion tree method, now you can see that this is very simple recurrence relation which we can solve it directly by substituting, and what we may get is big O of n log n, right? So big O of n log n, if we solve, we may get with our actual substitution method. But now you can see that if I go with recursion tree, I got with n, so that's why we just choose it to theta of n. So for simple recurrence relation, the recursion tree example is not necessary to go with this method, because this method will also give us some approximate result. So what kind of example we can choose? So let's choose one more example which is a little bit complex. So when we go with just replacing n twice, so if you have equation something like this, that t of n equal to t of n upon 4 plus t of n upon 2, and local computation time is n square. So what happens here? We have divided one problem of size n will be divided into two different sub problems. One is of size n by 4 and another is of size n by 2, and the time, again local time required, is n square. So now what is happening here? N is replaced by n by 4 once, and again at the same stage n is replaced by n by 2. So same way this n square also will change. So now where that n square will change, you can just check. This n square will be replaced by first n by 4, that is n upon 4 whole square, and at the same stage this n is also replaced by n by 2, so we will be getting n upon 2 whole square. So now what we got? N square, and to this we got n square by 16, and this is n square by 4. Now again this n by 4 whole square, that is n square by 16, will be replaced again with n by 4. So now what will happen? Again n by 4 is n by 16 whole square, you can see that, and this is n by 8 whole square. Just I am replacing n with n by 4 here, n with n by 4 here. So this is n by n by n upon 4, and this is n upon n by 2. So what will happen? This is 4 into 4 16, and this is 4 into 2 8. So n upon 16 whole square and n upon 8 whole square. And for this also, if you just check, I will be getting n upon, when I replace n by 4, it is n upon 8 whole square, and this one is n by 2, it is n upon 4 whole square. So now these terms will become, see, n upon 16 whole square is n square by 256. Then if you just see here, it is n square by 64. The power of 8, square of 8 is 64. This is again n square by 64, and this is n square by 4. Now same process will continue. So I just don't want to go with I'll just show the dotted part of this. But now what will happen? Now start summing the total number of n's, like how much is the thing at each stage. So I'll sum these things, what I'll be getting. So if I make base as a 16, common base as a 16, what I'll be getting? So this is 4n square by 16, that is I got 5n square upon 16 at level 1. At level 2 I have to make base as a 256. So if I make base as a 256, I'll be getting n square by 256 plus this one is 64 into 4, I guess, right? So 4n square by 64, 4n square by 64, that is 4n square by 256, 4n square by 256, that is 8n square by 256 plus 1n square, that is 9 times n square by 256. And when I have base 4 here, just divide 256 by 4, what will be getting? 4 6 are 24 and 64, so plus 64 n square by 256. Now 64 plus 9 is 73 n square by 256. So I got here 73 n square upon 256. So similar way we will be getting some values here. So now you can see that I can get total complexity as n square plus 5 n square by 16 plus 73 n square by 256 plus so on. And when I take n square common into this, I'll be getting n square here, and then 1 plus 5 by 16 plus 73 by 256 plus so on terms, and this will again form for us a geometric progression. So this is a geometric progression which we are getting, and which will give us some constant value again. So we got again the complexity. Now the complexity of t of n, which is equal to t upon n by 4 plus, t of n by 4, t of n by 2 plus n square, using, because I should mention a recursion tree, using recursion tree method is theta of n square.